Hello everyone. Now we are looking at problem 79. So this is word search. So given an n times n grid of characters board and a string word, return true if word exists in the grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter may not be used more than once. Input. Alright, so let's stop there. And let me reread the problem to make sure I understand it. So we are given m times n char character board and a word string. String word. So we want to return a word in board. Okay. The word can be constructed from letters of sequentially adjacent cells. Adjacent cells are horizontally or vertically neighboring. So that means we could move 4 directions. We could move up, down, left, and right. And the same letter cell may not be used more than once. Okay. No repeated cell. So that means we could not repeat a cell. Alright. So now let's look at the examples here. Example 1. We have A, B, C, E. Let me rewrite it to be more spacious. So A, B, C, E, S, F, C, S, S, L, C, S, A, D, E, E, A, D, E, E. Now the word is A, B, C, C, E, D. A, B, C, C, E, D. Now this is A, B, C, C. Yep, this is true. So we start from A at the 0.0, and then we'll move right, move down, move down, move right. So that is true. Second example. Again, this is the same block. Yep, it is the same block. So let me just call it 1A and 1B. So B, we are looking for C, S-E-E, which is true. And then let me just separate them. Second examples, A, B, C, E, S, F, C, S, A, D, E, E. Now C, if you are looking for C, that is true. So we start from 1.3, then we move down, we move left. So that is SEE. Okay, now we are looking, see if we have a question 3. And we do. So question 3. So the same block, yeah, I think so. A, B, C, E. SLCS ADEE. Now we are looking for ABCB. This is false. Alright, I think I got the question now. I would like to clarify a few things. First one is the size. What is the size of board? Either M and N. So we are given M is board length, N is board length. So it is between 1 to 6. So it's quite small actually. And how about the length of word? So the length of word is given by 1 to 15. Okay. Board and word consists of only lowercase and uppercase letters. Right, so there is a follow-up question. Let's go through that after we solve this problem. Alright, so I think I got the questions now, and I would like to start thinking about some possible approaches. On top of my head, what I can think of is that with a brute force approach, we could go through all the cells, since there are like 36 cells. So we go through all of them to see which one have the start of our word. So for example, in example 1, the word is A, B, C, C, E, D, so it begins with A. Now we are looking for cells that has an A in it, which is cell 0.0 and also 2.0. So we can start from there and then try to move. Okay, let me write down the step here. So step 1, find word I in board. Now, if we have found it, then we just need to explore all the possible choices. So we could move right, move up, move left, move down, as long as it is between the boundary of the board. And then there is also another criteria that we need to consider, which is we may not repeat a cell. So how are we going to do that? Well, one way to do that is by using a visited set. What we're gonna do is that there are two possible ways that I can think of for now. One is to use a set that contains all that will store the coordinate of the cells. Or I could also use another board to represent whether I have visited that cells or not. Actually, let me think about it for a moment. If I don't want to use a set and I don't want to use another board, how about I just modify the board itself? So what I mean is that in here we are looking for the every letters in word. If we set a cell to an empty string, then it won't visit that cell in particular because it doesn't match with the current character that we are looking for. So I think that is a possible way. But let me skip this for now and then just write a generic approach here. So in step 2, you're gonna explore for direction and mark And we also want to mark current cell as visited. Okay, once we mark it as visited, we are gonna visit it again. So this the way we mark the cells will depends on how we want to do that. And as I mentioned, we will explore this further later. And then in the third step, if we don't find the cell, if we don't find the particular word that we want, then we just return false. Can we do that? I think we could. So, alright, here it is. I think we could just return result of order for direction. So we could order them. For direction. Step for marking. So now let's move on to the second part that we would like to, that I want to explore. So I think the first part is good here, i.e. we find the word and then we explore four directions. But at the same time, we mark the current cell as visited. Then we move on to another cell and we move on to the next character in the word. At the end, if we don't find any solution, then we return false, otherwise we return true. Now, let's discuss about the step for marking as visited. So as we move on a step, one second, let me pause here. Alright, so here we are, how we're gonna make it. So first one, as we enter the cell, we store it into copy into dummy, copy the, what we can do is we copy current cell into dummy, and then second, we step into four direction, move to neighbor, and then as we return, we are gonna reset the cell into its original value. So you can return and set the value back. Okay, so I think this could work. I would like to go through the examples here. So examples 1, let me just reboot the board. So A, B, C, E, S, F, C, S, A, D, E, E. And we are looking for A. So we go through all the characters and then we find there is an A. And then we move right, there is B. Then we move on, there is C, and C, and E, and E. In the end, when we reach the end of the character, we just return true all the way back. And then towards the end, we return true. So step R. Okay, so in this case we have found our solution directly. Second example, A, B, C, E, S, F, C, S, U, T, U, E. Actually, let me just okay, so let's go back to the first example. We have an A there, but A doesn't go to anywhere, so we return false. Yeah, so A is false, and cross that. And then the second example, we would like to find C. So S, E. So there is an E above the S, but there is no further E, so we return false. But below that, there is SEE. Okay, so that's not that. And then third examples, we have A, B, C, E, S, F, C, S, A, D, E, E. We would like to find A, B, C, B. So we have A, B there, but there is no C, B. A, B, C, but there is no B. Then there is A. Okay. So I think this could work. As for the complexity, I think in the worst case, we are gonna explore ourselves, and then we will go through all the character in Word only to find out that we don't find any solution. In that case, that would be O of n times the length of Word. So I think that is still pretty small, and I guess that is pretty efficient, so we could use this solution. Solution, I am pretty good about this. May I proceed to program? And I assume it is yes. So now let's move on to coding. So we are given the function exists, and the input is word, board, and word. So board is a list of string. And then the word is string. So I think I'm gonna do this recursively because it is easier. Now let's move on to the coding. Here in the recursive function, what we need is we need to keep track of the current position of the word. So and also we need to know the position of the current cell in the board. Now let me define that now. So we create, I'm gonna call it, let's see, I just call it search. Yeah, search, and then let's say M and N. So we have M and N, and then the I. So N and N represent the position in the board, and then I is the current index of the word that we are looking for. n. So now let's do that. Here, first of all, we need to check if we are out of bound. Actually, let me just call it, instead of m and n, I will use another variable. So let's call it the x and y instead. So we need to check if 0 x and m. So if not and 0 y and return false. Otherwise, we check if the current is, so otherwise it means the x and y are valid, so we can check the cell. So if both of x, y is not equals to word of I, then we return false. Otherwise, we store the current cell to a dummy equals both of x, y. And then we set the bot to empty list and empty string. Now it is time for us to explore all the 4 directions. So what I'm gonna do is, so I think let's see how we're gonna do this. Okay, I'm just gonna assume I have a direction. So I'm gonna look through the direction for dx, dy in direction. I'm gonna search x plus dx, y plus dy, I plus 1. Actually, it's not just search, you need to return it. Actually, no. So what we're gonna do is we need to define if there is a solution. So solution, is that a bitwise or let's see, Python or equal. Okay, no, forget about it. So here I'm gonna call a variable called found equal false. I'm gonna assume we don't have a solution. And then what we're gonna do is we set the found equals found or. So as long as any of the direction has a solution, then we will just return it. Okay, so at the end, we return the found. So now what we're gonna do is we need to call the function. Of course, we need to store the n and n. So n is length of both, n is length of both of 0. Then I'm gonna return the search of 0. Actually, we need to explore all the cells. So search, and then okay. Other than that, we not need the direction. So let me define the direction as let's see, left minus 1 0 1 0 0 minus 1 0 1. Okay, so now we need to go through all the cells and then see if we have any solution there. Yep. So let me call another function here, call it if initialize as false, initialize as false. Therefore, I in range length of m, and then for j in range of n, I'm gonna check if there is a solution with the cell. So found equals found or search at ij0. Okay. Now let me go through the code again to make sure I haven't missed anything. I'm gonna store m and n as a boundary. M is the height and n is the length. Okay. And the direction, there are 4 directions, which is move left, up, right, and down. Store it inside the direction so that in the future I can just look through all the direction here and then easily move around in the neighbors. Then I'm gonna iterate through all the cells to see if there is any solution that starts at that particular cells. In the search function, I'm gonna firstly check whether the x and y are out of boundary. If it is, then that is not a solution. Return false. And if the current cell is not the word, the character that we are looking for, then it is also not the solution. So we return false. And then, okay, so I missed one thing here. So I store the value inside dummy, but I forgot to set it back to the original value. So let me do that here. X, y equals dummy. So I'm assuming that I can modify the board as I move along. But in here, I will set it back to the original board after I return. Okay, so here in the forward direction, I'm gonna check if there is a solution. i.e., after moving there, I check whether there is a next character. If there is a next character that I'm looking for, if there is a next character in word that I'm looking for. Actually, in here, I need to check if, okay, let me do another thing here. So if the If we have it source all the character in word, then we need to return immediately because there is no point to check the next one. So here we are gonna check elif the I is the length of word minus 1, then we return true. Okay, so it means we have found all the character in word. Then at that point we don't need to search further. Okay. So once we search all, then we set the bot value back, and then we return the font. Okay, I think that completes the solution. Now let me check with the input here that we have. So we have A, B, C, E, E. In the 0.0, we have A, then we move right. We have D, we have C, C, E, E. Then at that point, we return true. So another thing that I forgot is return the font at the end. Yeah. Second example, we are looking for SEE. The S in the first S, we cannot move around and find the E, so we return false. But the second time we see the SEE, we found the solution, so we return true. Third example, there is no solution there, then we are the font will remain false. Alright, now let me quickly code it into LeetCode to make sure it works as expected. Okay, so we define search x, y, and I. If not I is not 0, x dot n, and zero y self dot n return false. If bot x y is not equal to word of I, then we return false. If I is the length of word minus 1, then we return true. Otherwise, we need to store the dummy, then bot x of y. So this would be bot x y, comma empty string. Then for dx dy in direction, we are gonna search it. Okay, don't forget the found equals false. Found equals found or search x plus dx y plus dy I plus 1. In the end, we set that the port value x, y equals dummy. Then step 3 and then we return the found. Now n and n, this would be length of port, length of port 0, direction are -1 0 1 0 0 1 and 0 -1. Then we look through all the cells. J in ring n. We need to initialize the found. So found is false. Found equals found or search. I 0. I think we don't need to found here, so we could just return it directly. If search ij return true, otherwise at the end we return false. Now let's test this. Solution has no attribute m, so m is, let me just send it through self. And the direction. So yep, I think this should work. N is not defined, you mean n set in the set. Yep. Okay, we got it right. Now let's try to submit it. And yes, we got the correct solution. I think it's pretty efficient and as expected. Now let's look at some examples from other submission. This is quite lengthy. This is using toolbar. Okay, so I think there are many ways to do this, definitely. And but basically the idea is to use backtracking to find the solution. So yeah, I think we would stop here, everyone. And thank you. We will look at other problems later on.